Okay, we're going to talk about classical, empirical, and subjective probability. So before we look at these problems, let's talk about the three methods of assigning probability. So first we have classical. Okay, so this is used, an example of this is like rolling a dice or drawing from a deck of cards, because it's used when the possible outcomes is known. Okay, so in the previous video we did calculate classical probability. Another thing I like just to add on this is based on prior knowledge, so we know the probability already based on, we know the number of outcomes. So if you roll a dice, you know there's 6 outcomes and you can calculate the probability. Drawing from a deck of cards is another example. Flipping a coin would be another. Okay, so the next one is empirical. So this involves conducting an experiment to observe the frequency with which an event occurs. Okay, so this one depends on observed data. And then the last one is subjective probability, and this is used when you can't do classical or empirical. So instead they use experience or intuition to estimate the probabilities. So there is no way to compute it. This is what we use. Okay, so let's look at our homework problem. All right, the probability that 6 coins will land on heads. Okay, so we know that we can calculate this based on prior knowledge, so that's classical. And the probability that a company's new product will succeed, well, there's no way to compute that, so that's subjective. The probability that there will be at least 15 tropical storms in the summer, well, this was going to depend on observation, or we're going to have to do an experiment and watch during the summer and see. Then D, there is a 0.65 probability of randomly selecting a student who has a part-time job. Okay, so here this is going to also depend on observed data. So this is empirical. Okay, in this question, a survey was conducted for 125 families, and they were asked how many cats lived in their household. And so what is the probability that a randomly selected family has 1 cat? So 1 cat would be 25, and 25 divided by 125 would be 0.2. What is the probability that a randomly selected family has more than 1 cat? Well, more than 1 would be 2, 3, and 4. So if you add those together, 17 out of 125, you can calculate that just to check, but it would be 0.136. And then the probability that a randomly selected family has cats, well, that would be 1 cat all the way up to 4. So if you add those up, that would be 42 out of 125. And then the last one in this example of class, is this an example of classical, empirical, or subjective? This is empirical because we are observing data. Okay, so that is how you work empirical. Let's look at this one. What percentage? So here we have 300 adults responded to a survey asking them to name their favorite national park. So this is observation. So this is empirical for sure because we're counting our results. What percentage of respondents chose the other category? Remember, they add up to 100%. So 30, 48, 60, 70. So this would have to be 30. Other respondents, how many selected Park A? So you would take 30% of 300, 0.3 times 300. And then other respondents they selected part C or D, you would add those up. So 22% of 300, which would be 66. Okay, let's look at the last one here. The table to the right shows the frequencies of exec salaries ranging at a particular organization. So here we want to know how many execs at this organization earned 100,000 or more per year. Well, the total is 20 for the frequencies, so we have 18 already. So this would have to be 2 in order for it to add to 20. And then 100 or more, the probability of 100 or more per year. So you would take the amount of the frequency, which is 2, and divide it by 20, and you would get 0.10. The probability of a randomly selecting exec who earned 60,000 or more. So 60,000 would be everything but 4. So that would be 16 out of 20, which would be 0.8. And then the probability of randomly selecting an exec who earned between 70 and 90 a year. So 70 to 90 would be 8 out of 20, which is 0.4. So you're just looking at this and you're looking at your frequencies and dividing it by your total to get your probability.